we've already heard a snippet of what Dean Nelson's going to talk about. It's really about how do you create the ultimate feedback loop that affects change. Please welcome the Vice President of Global Foundation Services at eBay, Dean Nelson.
Thanks. Good afternoon. Everybody hear me? Okay, I dressed up for you and everything. My name is Dean Nelson, and my job at eBay is to run physical infrastructure. So that's data centers and network and compute services. And I have a great job because we serve a massive community. But I wanted to talk about eBay specifically. eBay Inc. right now enables $175 billion worth of commerce globally. $175 billion worth of commerce. And eBay.com, the marketplace, is $68 billion of that actual commerce. So what I want to do is walk through. Today, we have about 120 million people, active users, that are actually using eBay. And we have, at any given second, 450 million items for sale. Any given second, you can find almost anything you want on eBay, whether it's mobile, whether it's laptop, whether it's desktop. We have a huge inventory on our site. That's everything from cameras, to coffee makers, to clothes, to cars. And I don't know if you know, but we sell 9,000 cars a week, okay, through eBay. And by the way, that metric is just through mobile devices. Yes, people are buying cars, buy it now, standing in the line at Starbucks, buying a car. And one of those transactions I love is there was a Porsche Carrera GT, sold for $269,000, and it was right through an iPhone. We sell everything, almost everything on eBay. But what I wanted to do is, what does that mean to the infrastructure underneath? So I want to walk through an actual transaction. Okay, let's follow the journey of one of these transactions that happens inside of eBay. So I am looking for a brand new car. I have a hardtop convertible, but I want to get a new one. And I thought these BMW Z4s look really slick. Okay, and it's yellow. It looks like Bumblebee from Transformers, so that's a good thing. But here I go in and I pull up my eBay mobile app. Anybody here use the eBay mobile app? Ah, those of you who are not using it, you're missing out. This thing is awesome, okay? Just for mobile, just for gearheads, just to find what you're looking for. So I go look for one of these. And lo and behold, I find this Z4. Great, $58,000. Okay, we'll see. And you buy that car. So what does that mean? In the infrastructure side, what I do in my job is deliver for those transactions, for those requests that come back from those 120 million people looking through those 450 million items. So as we walk that journey of one of those transactions, well, usually what happens when you pull up your device is you do a search, you're looking for something. That initiates a request. That request goes over a network, and it ends up in a data center. Okay? And what is a data center? A data center is a great big building full of tens of thousands of servers that are serving millions of people. So all of those requests that come from all those different users go back through this data center and are processed and return results. Okay, so for example, this is one of our data centers in Arizona. This happens to be representative of 2,000 servers and 400 square feet. Very dense, 2,000 servers serving millions of customer requests every second. And we get free cooling year-round in there. Anyways, different thing. Once it actually does this computation, so I'm going to assemble the picture, the price, the listing, the description, all those elements. I put that back together and it goes back over the network, and then your device now actually displays what you're looking for. But what does that mean underneath? Here I made a request, did something in the data center, and came back over. Well, ultimately, this is generating revenue for us, right? We have listing fees and other things that we make money of enabling all these people to find what they're looking for. But ultimately, from my standpoint, it consumes electricity in the data centers. Data centers are growing. We are big power consumers. It also has an overall cost, whether it's depreciation or kilowatt hour costs, utilities, the actual buildings themselves, the servers, et cetera. So there's an economic cost to it, but also there's an ecological cost. Every kilowatt hour we consume has a carbon footprint to it from the power that we're actually generating from whatever source that it's coming from. So the big question for me has always been, how do you measure the productivity of this infrastructure? So give the example of a car. When you get in your car, that car is designed to do a certain miles per gallon. Great. But the miles per gallon you actually get, they said varies, is how you drive the car. So who's driving our car? Our 120 million active users. Who designed the car? Our team. Is it effective? Not sure. We need to figure out how to measure that. So we came up with a metric. And this metric and the dashboard that they were mentioning before is digital service efficiency. Okay, this is the efficiency of delivering electronic services. The efficiency of delivering electronic services. Everything we do at eBay breaks down to two services. People buy stuff and they sell stuff. Pretty simple. Everything underneath it to be able to deliver those services is a cost, an economic and an environmental cost. And the results of all of that turn into the revenue that we generate for our shareholders and our company. All right? So I had to have quite a few conversations with the C-suite to try and get this right. 3 years worth of work to try and get into a metric that would actually measure and be effective for our C-suite. And all the conversations were around, I don't care about kilowatts, kilowatt hours, bits, bytes, whatever. Tell me what the business value is. All right? So let's up-level this conversation and see how we can measure that business value. What came out of this was a single dashboard, like you see in a car, of the performance of that system. Okay? And there's a reason I have this Rubik's Cube. Everybody's played with these at once in their life. We saw this as a 4-dimensional problem. Because you can go back and design a killer system that's going to deliver maximum performance, but it's going to cost too much. So we look at it this way. Performance for us is every one of those requests that comes through a device is a transaction when it goes into the data center. So count the transactions coming in. And I can now say, well, how many kilowatt hours do I consume to actually serve those transactions? Miles being transactions, gallons being kilowatt hours. So the transactions per kilowatt hour turn into the performance of our engine, the miles per gallon we're getting for technical infrastructure. But that's not the only dimension you can look at. You also have to look at cost. So I've got transactions per kilowatt hour. I flip it on the cost side, it's cost per transaction. So my denominator becomes the transaction. That's the economic side. But what about the ecological side? How about my carbon per transaction? Interesting. You've got to start solving all of these sides together. But ultimately, we need to be able to solve what's the revenue per transaction we're generating with a balanced ecological and economic engine that's being built and operated by our customers. That's a mouthful, but ultimately our customers are driving our car and we want the most cost-effective, highly productive, and environmentally friendly engine delivering for those customer requests. So what we came up with was this dashboard. And what you see here, it's pretty simple. There's the infrastructure to deliver everything on the left, and then there's the actual business KPIs that our C-suite care about. So you can see that on the bottom, well, a little hard to see, but we have the grid. Where are we getting our power from? How clean is it? How dirty is it? We have X amount of owned and X amount of grid energy that's coming in. And if you see on the top here, this is Q1 of 2012. You can start to flip through these things and see that things change every quarter. Okay? So the amount of power coming in. Well, we know that in that quarter, which happens to be Q4 of 2012, we had 112.5 million active users at that point that were requiring 52,075 servers in the data center and sustaining 20 megawatts or 19.43 megawatts worth of power consumption to deliver it. All right, I have all of my variables to be able to now know what my infrastructure draw is. Now let's look at the productivity. So on the right side, my carbon. What's my carbon per user? Carbon per server. Carbon per megawatt hour consumed. How about cost? What's my cost per user? Cost per server. Cost per megawatt hour consumed. And ultimately, how much money are we making from our infrastructure per user, per server, per megawatt hour? It connects all the dots and allows you to solve the Rubik's Cube, the technical infrastructure challenge, at one time. And you can now make the trade-offs and balance out your ecological and economic and your performance for ultimate revenue gain for your business. So this became a very simple way for us to go back and measure the productivity of the infrastructure that we build to serve those customers. This is the 2012 baseline. We have all of our transactions, and our transaction is a URL request. Every time you go in and actually do something, a request goes through a URL. We had 4.3 trillion transactions or URL requests in 2012. That is only the user-initiated transactions. Now, orders of magnitude bigger behind it to serve all of that. But we measured the actual user requests that way. And you can see the goal or the performance as we go forward. These are the numbers for Q2 that we released for 2013. And overall, we're driving down, we've set a goal for the net gain of this. We want a 10% increase in actual transactions per kilowatt hour, with an actual 10% reduction in cost per transaction, and a 10% reduction in carbon per transaction that's actually emitted. So you can see more about this on our new site, which is tech.ebay.com, and follow the transactions that we're actually generating. Thank you very much.
Thanks, Dean.
Thanks.